Hello, everyone. This is Jason Key at Harvard Medical School in Boston. Thanks for joining us today. Today is my pleasure to introduce Jose Miguel de la Rosa Trevin, who is joining us from Sweden. Jose is the developer of Scipion. So if you're not familiar with Scipion, Scipion is a Cryo-EM processing package that takes advantage of its own built-in tools, but also the capabilities of a number of other software packages including Relion, Freealign, Eman2, and many more to give you the options on how to process your data using all of these tools within workflows that are documented and built within a graphical interface. And I think it's an interesting and ambitious project, and it's gaining lots of users, I know. It has a number of fans. So today, Jose is going to talk to us about how to use that for stream image processing at Cryo-EM facilities. So, Jose, are you there?
Yeah, I'm here.
Yeah, go right ahead.
Okay, thanks a lot, Jason. It's really a pleasure to be here sharing with all of you, in particular to stream image processing. So before starting, I want to thanks for this opportunity to the SB Grid initiative to hosting these seminars. I think they are quite important for the whole scientific community, and in particular to Jason and Michelle. So before starting, as Jason mentioned, I'm working now in Sweden. After a year or so, I moved. I was before in Madrid, where this project has started, and the main team also is there still. I work in SciLifeLab. There is a kind of a national center that is hosted by different universities. So we have a Stockholm University, KTH, Karolinska, and Uppsala University. So you can see around all these campuses is distributed SciLifeLab. The talk today, I want to kind of divide the presentation in two main blocks. In the first part, I would like to present a little bit an overview of the framework. In that sense, I would like to show you the main project goals that have driven how we have designed and implemented this whole framework, and some of the achievements that we have made for users and also for developers. On the second part, I will focus more on the recent features that targets more on the fly or streaming data processing that has been quite popular among EM facilities and also some other users. First, I think I will start with some of the problems or in the field that has motivated us to start working on this project as a first instance. And then I always use this slide and I call the Babel Tower in terms of software packages. So we have, it's a good thing in one sense that we have many options and many tools that we can use in Cryo-EM data processing. But at the same time, it's quite messy and difficult for a user to combine different programs in a whole project and convert data from one format to another, the conventions of rotation. All this, I think, is unnecessary and then a big problem that we can try to solve and allow more time to analyzing the data and focusing more in the scientific problem. Another big issue that I feel is not only in Cryo-EM, but in general in science, is reproducibility. So in Cryo-EM, it would be really nice if we can just download the raw data and then follow the procedure of a given paper. Right now, I feel that is quite a miracle, as in this slide says, that to follow the whole pipeline with the same parameters and then reproduce somehow the same results. We can also think in reproducibility as the first step for validation as well, that decreasing the threshold for allowing other people that cannot follow the same pipeline. And then another important thing that we face in Cryo-EM is that the computational needs are quite heterogeneous. I will say for some steps we need more like graphical interface or GPU, where there are more graphical oriented jobs, or in some case we need more computational power with CPU or big disk for I/O, for fast I/O. And then also moving all this data around is in the shoulder of the user right now. I think also it was a requirement for such a framework to try to automatize and we try to improve all these problems. So when we started in this project, we tried to kind of focus in very specific goals, because in software development, it's quite easy that we can get distracted about technology and then very shiny and new frameworks that can get you distracted from the main goal. So we try to say, okay, the first thing we try to solve is integration. We want a researcher can use many software packages in a smooth way to complete the whole processing pipeline. Then, since we were taking this way, we wanted to also provide traceability and also improving the reproducibility of the whole processing. And of course, also addressing automation and workflow-oriented execution. And then the last 2 points are not less important. We wanted to make it as easy as to use as possible. And the last one, we wanted also to be extensible. We recognize that the field is growing quite fast, and then it will be very, very important from the beginning that the framework should be designed in an extensible way. So it means that it should not be kind of a monolithic system. Before Scipion, as far as I know, the only real approach trying to model and combine different programs was Appian. And then one of the main limitations, in our opinion, was the attachment to the database. Was a design, but quite problematic to extend with new functionality. So one of the first steps we did was trying to model all this processing, something that is quite common in software development. Try to create a data model. So it means that trying to separate the file formats and specifics of each program from more abstract concepts. For example, in this slide, we represent in boxes the processes or protocol we call, and in these ellipses, we represent the data type. So in that sense, we try to model like set of images, set of volumes, CTF, movies, and then this is a more abstract concept that the underlying data files that could be MRC or TIFF, or you can represent the metadata in star files or HDF files. But then having this model, it can allow us to define all of these steps in more a workflow-oriented manner. We did the same with the protocols. So we define a process model where a developer can focus also in defining different steps and then hiding the internal of these steps. So these steps could be translated to calling a given program, preparing files that allows to go from one program to the other. And all this, the user can deal in different levels. So it can see as boxes and a more general and overview, or can go more into detail and check what is going on behind the scenes. Also, in the implementation, we try to not to make it couple the design of this data model from the persistence mechanism. So now we are using a file-oriented database, SQLite, but then this is transparent for a developer of a given protocol. So it means if you are a developer, we try the developer focus more on the computing task in the program that is trying to wrap and not need to deal with database or queries. And then this layer, we call the mapper layer, will handle storing and retrieving data. And then you will iterate or use the objects in a more API fashion. Also, something that is built in or provided for the users, but the developers can also benefit from that is this graphical interface. This is the main project interface. In the left panel, you have like a list of all the protocols that are available for you. This is a kind of a general grouping for single particle protocols, but this can also be customized. So you can, it's a configuration file that you could change and modify, and then have a list of the most used programs in your lab or the ones that you prefer to use for a given task. In the right upper panel, you see the whole history of all the processing. This is a tree view, but you can also have a list or a shorter view. You can collapse many of these nodes, and then it's really easy to track all the processing that has been done and all the parameters and follow different branches. It's also very easy to kind of copy branches, or all this workflow can be exported to a template. We call it's a text file, a JSON file, and then this can be imported or shared with colleagues or with the students. And it's very easy to kind of have this template and start a new project with different sample and repeat some of the steps. And in the last, in the lower panel, you can see some summary of the process. So it's very clear what are the inputs and output of each of these steps in the workflow. And then you can also dig more and then see all the outputs that has been doing or reference to the given paper of these methods and more information about this operation. Something that is built for the developers: when you add a new protocol, the system will generate automatically, based on the parameters, this graphical interface. We call this a form for filling up the parameters, and then it means that you don't need to develop a new form. That this is kind of cumbersome and details about writing the graphical interface. And then when you search for input, we don't deal with files apart from the import. So it means that a developer can say, in this example, is a spider filter particles, and then you can say, okay, the input here will be particles, and then when you browse, the system will provide you as options only the particles in your project. There is no mean that you can plug in micrograph or volumes or get this run anyhow. And then we have also built in more handmade graphical interface that we call wizards. These wizards have the function to provide you a real-time preview of the operation. They are quite handy in some cases. For example, this filter, you don't need to figure out in your mind how a frequency will affect your images. You can just change the parameter and see how this will affect, or in some other cases like selecting mask or CTF frequencies as well. This wizard needs to be done manually somehow, but you can reuse some components. So it's also kind of a adding tool for developers. Also, we have developed some graphical analysis. After you have finished like computing, you could analyze the particles that have came after refinement or classification, or the 2D classes that can be grouped. And the good thing is, since we have integrate all these packages, all the graphical interface that are developed on this layer can be reused for any classification that is integrated. Like if you do 2D in EMAN or Lion or XMIP, for all of them you can have the same interface or add the new ones. So we have been also using the whole framework for training. From the very beginning, we started with the prototypes or alpha and beta versions. We spread the word and use for teaching. In 2017, there was a longer workshop that was hosted by FEI and used for training. And then, well, this is we always try to continue this work of sharing the knowledge and training new students and postdocs. So just check. I will provide the links to the project at the end. So there are always announcements for new courses and workshops. So for the second part, well, as you know, we have been talking or witnessing this revolution in Cryo-EM. I'm not going to repeat or talking about the number of maps, the increased number of maps, or the improvement in the resolution. And then last year we had the Nobel Prize for 3 of the pioneers in the field. But then I want to look at this revolution in the software perspective. So what are the challenges and the change in requirement that this revolution has imposed? In the early days of Cryo-EM, it was more like a handmade processing, right? It was just a few bunch of tools, and then a very few labs developed software. The user were either the developers or were very close to the developers. And then you need to be very expert in the field to kind of very skillful to get a reconstruction. Nowadays, this has changed a lot. We have now many more software packages. There are many more tools. And of course, we want more and more automation. We are buying all these very expensive instruments, and then we want to have high throughput. So this has came into a new changes we have made to the whole framework to trying to adapt to this new requirement. Something that people has started to do was like trying to process the data or pre-processing as soon as the data came from the microscope. So we are calling this streaming processing or on-the-fly data processing. At some point, we were calling these changes as Scipion box, but then we don't want to use this name anymore because usually people get confused and think that it was a different installation or just a machine. And then right now we have like modified the framework just to deal with this new stream of data. Before, once a protocol started, it only generated the outputs once it was completely finished. But of course, in that case, you need to wait until importing all your data set. Then you need to do motion correction on the movies. You wait for that, and then you start a CTF estimation. Of course, this was not effective because you could reduce the computational requirement, and then as soon as you get one data from the microscope, you could start like pipelining and doing this processing and streaming. And then we can also think in the data stream not only as the microscope. So imagine that you are also downloading the data after you went and you collect data in some facility, or you are downloading from NPR or uploading to the cloud. There are many streams that can benefit from this on-the-fly data processing. So in the previous version of Scipion, we advanced this streaming until CTF estimation. And then what we needed to introduce was a change in the data model somehow. Now we needed to incorporate the concept of open streams or open dataset. So it means that the import protocol will keep looking in a folder for more data, and then it will create a set and will update it. So it means that the movie alignment will know about new items that were being imported and then can align and pass to the CTF estimation. Something that we also developed on top of this streaming was something special protocols that we call monitors. There were protocols that were in charge not of computing, but checking and raising alarms or just providing a summary or overview how the streaming processing was going. Now we have also implemented particle picking. So it means that on top of CTF estimation, now you can set up the particle picking programs, either by training a little bit in a subset of micrograph, or like in template base, you can import some previous templates and then launch the particle picking. And we're also testing with some 2D classification as well. So we are kind of using now creating subset of the data and scheduling Reliant or other 2D classification algorithms. This is an example of one of these monitors we call the summary monitor. So it provides just a preview of how many items has been imported, how many has been motion corrected or CTF estimation. And then you also see here a very simple report that we generate is a HTML file that you can synchronize to your own web page because usually this instead of outside connection. So it means that we generate this report and then you can synchronize or copy over the network and then have this online and real-time preview of what is going on. This is kind of a very simple monitor where we generate this information, but we also have been collaborating and integrating more advanced monitor. For example, there is a system called iSpy-B that is using synchrotrons here in Europe. I don't know if in the US as well, in Diamond and the ESRF. This huge system tracks the sample and then the beamline usage and all the project all the way. And then this is in place in Diamond and in the European synchrotron. And in a collaboration with them, we developed a bit more complex monitor that were reading the information from the Scipion streaming processing and then was feeding this information to this system. So in this case, we don't need to generate this HTML and then the viewer of this report was the system they already had in place. Something that is different in this approach in Scipion is that we modify the underlying infrastructure just to allow and compute on the fly, but then it's the same framework. So here in the Swedish facility, we usually every day provide this on-the-fly data processing, and then the users get together with the raw data all the project, and then they can just review what was done or continue from this point, or reproduce and repeat some of the steps with different parameters. It means that it's not a kind of a script-based approach where it's difficult to kind of extend in the future with new algorithms or just provide them reproducibility for the users. Something that we also kind of has developed in different ways is what we call session wizards. That is simple tools or scripts that helps to kick out the processing. In this example, I'm showing here more or less a diagram how we use here in Stockholm. So we have a national portal where all the projects go through and then apply for time. They are evaluated and then granted access. And we also have a booking system that is more internal, and then the Microsoft operators kind of allocate time for internal projects or external projects. And then this wizard is just a simple graphical interface that reads the information from these two sources, and then it will prepare kind of the data organization where it should be stored, the raw images, and also the processing data, launch some copy script from the camera computer to the processing server, and then we are also logging this information of all the sessions. Right now, we are not doing any statistics or analysis on that, but it will be that we store the information and then we can extend all this functionality later. In Madrid, for example, they have also created some kind of web interface where you do similar things and set up the processing project. This project, one of the main goals also was to provide infrastructure and access to the state-of-the-art algorithms. That's why my former group in Madrid was committed in this Instruct, that is a European infrastructure where you can apply for microscope time, sample preparation, image processing. In that sense, we were committed not only to provide algorithms as in XMIP, but also provide this infrastructure. And then Scipion, from the early prototypes, we start to use in there internally in Madrid, and well, the 3DM map challenge was a great opportunity where we can test the whole framework and complete the pipeline and compare the results with the published datasets. And also in this Instruct or group, there was a Instruct Image Processing Center, and many projects has been supported by using Scipion as a processing pipeline. You can see in this graph many projects are in progress, other has been completed, and many European projects where this project has applied for support. Also, it has been quite adopted in many facilities, of course, mainly in Europe, but it's also now becoming more interesting in the US and Canada as well. Here in Europe, there has been 3 points where we have been driven the development of these streaming capabilities. One was in Madrid, of course, also here in Sweden, and then in Diamond. So we have a really productive collaboration, and now it's been adopted in many other places in Europe. So in summary, regarding the Scipion framework, I would like to highlight just a few things. Like, one is that we provide the integration of all these packages. So it means that we have developed a data model where we can convert from a given package back and forth, and we have like this common language or data model. And this is the basic infrastructure just to build new layers on top of that layer of visualization, or just adding new algorithm is much simpler having all these building blocks in place. And then through all this modeling process, we have ensure reproducibility and tracking. And I think it's quite important that share all the results with someone and be able to kind of follow all the steps. Also, comparing to other packages, many of the operations like subsets or modification of the data that is done manually and file editing, in Scipion we have tried to make a record of all this operation, and then it's there in the history. Regarding the stream data processing, well, we have modified the framework to allow these new requirements and new way of processing. And by doing that, we are now doing a more effective processing and reducing the computation needs. Of course, if you are addressing the data as soon as it comes, you don't need to deploy a big cluster to get all the results as soon as possible. So with a kind of a modest machine with 1 or 2 GPUs and some processors, you can keep up with the data acquisition rate. And then at the end of the data collection session, you can have a much advanced data processing for the whole project. And this is also very important to get feedback about the quality of your data, and then maybe take decision if you stop the session and maybe adjust some of the acquisition parameter or move to another sample and make a better use of the microscope time. And also I want to just give you here some links. All the project is open source. You can find in GitHub. There is also a web page where you can go and see for events there or announcement. It also, I haven't mentioned in the presentation, but there are also a few web tools. So it means that some of the algorithms, there is some web interface that you can explore and then check online without installing anything. And then just before ending, I want to say thanks to many people. Of course, the team there in Madrid and all the people that have raised the funding. Now in McGill, there has José and Javier that were kind of developers in Madrid, have moved to there, and they are pushing for software development in Canada. Also, I want to big thanks to Grigory Sharov, that has been a very enthusiastic person outside the team in Madrid. Before he was in Strasbourg and now he's in the MRC. He has been contributing a lot with experience in many packages and been quite active, and Joaquin as well, that have moved to Cambridge. And of course, this amazing collaboration with Diamond that has been somehow started by Juha Huskonen, and we have been working with Kevin and Alan there. And of course, the SciLifeLab here in Stockholm, that to the whole Cryo-EM facility, and especially to Marta Carroni, that is a facility head and was very keen from the very beginning to adapt, was one of the early adapters, and many of the feedback was translated in a very kind of a release when we address this version for streaming processing. And of course, all the other scientific group with Alexei Amunds and Eric Lindahl for all the support. And then this project, one of my motivation when I worked on this was build something for the community. And then I'm very happy to see that now more and more users are joining, and also some other developers that we have been trying to collaborate as much as possible. So I want to say a big thanks to all of them, and thanks to you for listening, and I will be happy to take any questions.
Great, thank you very much, Jose Miguel. If you have questions, you can send them by chat. I can also unmute you and you can ask them directly. We had a couple that came in during the talk. One is that as a question about, has the Scipion streaming and processing session wizard been installed in all the iNext TEM centers? I don't know what those are, but presumably you do.
TEM? Well, I don't know what TEMs are. Transmission electron microscope.
The iNext TEM centers. I don't know what they are, but well, I guess my broader question would be: is that session wizard, streaming wizard in the main branch on GitHub? Is that available now, or is it still in testing?
Yeah. No, the session wizards are separate repositories, so they are not part of Scipion. They use the Scipion API for kind of launching the project or set up the template. So maybe I might comment a little bit. So the original version of this session wizard, I started working in Madrid. And then when I moved here to Sweden, I just tried to make it a bit more general. But what I found was that the policy where the data was and the users was quite different from one place to another. And then, at least for these two cases, was not easy to reuse or make it so general. So it was kind of complicating the code that much. And then I think we have then as examples how you can use the Scipion API just to kick out the processing and streaming. So far, there is not a general solution. So there are, I know that also Grigory have forked this session wizard and created one from LMB, but it's quite easy to kind of set up and configure different microscope and different policies. Something for this streaming, we are not talking to the microscope or the data acquisition software. It's just, we try to start simple, and it's just a folder, and then we look for new data with a given pattern coming there, and then this is what triggers new items in the processing pipeline. And this also, as I was mentioning, can be used even if you are downloading data or uploading to a machine or wherever.
Yeah, there was another question that came in that's related. It said that is the copy script internal to the software itself, or is it using some different programs to move data? Or I guess that touches on a bigger question that I had was, are you monitoring on, I don't know, say the camera storage for the data coming in, or do you have some other storage directory that can be anywhere, network share, local storage?
Yeah, no. Well, the monitoring usually in Scipion we do in the processing machine. In our case here in Stockholm, we call this a staging server. And then the copy script, I will say that is quite particular, or we got from somewhere, is copying from the microscope computer to there. And also the setup changed a little bit when we installed the Falcon 3 cameras, because now they comes with their own file server. So I will say that this is also kind of a very site specific, but it's not a big deal once you have all the parts in place. Like either you could mount the drive or you copy. So I think there is not general solution, unfortunately, neither. Yeah. But yeah, usually the monitoring folder is where you are planning to do the pre-processing, kind of in the Linux machine.
Yeah, and then you probably touched on this. I'm sorry if I missed it. Are you carrying the processing through all the way to 2D classes, or where does it? Where are you finishing the stream?
Yeah, well, here also is a matter where you put the balance, right, between keeping this machine as small as possible in terms of hardware requirements and and also pushing the automation, right? You want to get as much data as possible. So far in the previous release, I think we went all the way until CTF estimation, and now we're also picking an extraction, so you get particles. And under development, we are trying now with the 2D classification. And of course, there is a compromise. You will need to have like either more GPU or more CPU if you want to keep the pace of the data acquisition. But until 2D classification, we are there. And then, of course, there is a way that how you can select the classes, good classes for maybe trying to build an initial volume and refine somehow. But the good thing is that we have all the infrastructure. So still maybe we need to refine or just see how the field is evolving to kind of automatize all these more user interactions to provide even more automation.
Great. So I have another question from Christina Polino, who is probably in Groningen, if I had to guess. Christina, are you there?
Yes, I'm here. Did you unmute me? Do you hear me, José?
You are unmuted.
Yeah, I hear you, Christina. Yeah.
Okay. But very nice talk, José. And I mean, I see, of course, the advantage of Scipion because it allows you to have a complete streamline also later on when you process it. But currently what we have installed in Groningen is the program Focus from Henning Stahlberg. Probably you know that as well.
Yes, I know.
Have you ever... So well, it's something that he just added up from his 2DX software. And what I really like about Focus, and it also allows us this on-the-fly data collection, but what it really allows is you have this wonderful interface where you can then also sort according to any type of thing. And the most important, and this is my question, if you can also do this with the Scipion, or if you intend to have this display, is indeed to have this sorting option, so that you still at the microscope, before you even bother about exporting and transferring your data, that you delete everything that is not at your quality standard. So do you have that also implemented, or would that even be possible?
Yeah, in the normal Scipion kind of project interface, usually after each process you have these analyze results, and then, for example, if you click on this analyze result after CTF estimation, you will get a kind of I didn't add a screenshot of that, but you will have a thumbnail of the micrograph, then you will have plots about the CTF fitting and thumb rings, and then this is the normal processing one. You can sort by any column, by CTF, the focus, or just an estimated resolution. And from this interface, you can deselect items, and then just in the next step, create a subset that you can continue processing. And then for the streaming, you have the same. This is the same. The web HTML report is a bit more limited option, because it's just a simple page that you can copy around, so it's not a server that is behind, like in the case of Focus, that as far as I know, has a web interface. And then, what we tried to do was kind of building something that could be extended, because in different places they have different requirements. In some cases, and smaller facilities or groups, maybe with just a simple report will be enough, or in some case, like in Diamond or ESR, you push this information to a system they already have in place. Anyway, I know that they have some other statistics. We have some issues to improve the reporting. I think will be useful to integrate. Yeah.
But José, from what I understand, it is indeed possible right now to also deselect
you
and
can
trash directly the bad things, that you just keep the good thing. Okay, thanks.
Yeah, while the streaming is going on, you can analyze the results in the desktop graphical interface and remove data from there. So and then you will not have this in the next steps. Well, what we have there, you deselect the items. What we don't do is deleting automatically, but this is something that also some other user has requested. So maybe we can provide this. I guess if you say that also deleting the files from the disk, right? Just to remove unnecessary data.
Yeah, but I would actually not be I would actually not be interested in automatically deleting it, because sometimes also there's some information in it, right? I mean, you
could be dangerous.
Know what percentage was good and so on. So but of course you would want to delete that, so that you don't keep the trash going on. Okay, yeah. I will then have a look at it. Thanks, José.
You're welcome.
Great, and I think if that's it, we can wrap it up. All right, well, thank you very much, José Miguel, and thank you everyone for joining us, and take care.
Okay, bye.